Everyone, welcome back to my YouTube channel SK Tech. In today's video, we are going to discuss about the Stream API in Java, and we are going to discuss overview of the Stream API, features of the Stream API, and also we are going to see the example of the Stream API. So let's begin. So first question comes is like, what is Stream API? So basically, Stream API is a newly added feature to the Collection API in Java 8. A stream represents a sequence of elements and supports various operations like, let's say, filter, sort, map, and there are much more operations supported by the Stream API. We will see with the help of the example, then we will see what are the advantages of that. Okay, so this is how it is going to be look like. We will be having some stream where we can perform all those kinds of the operation, where we can be using the predicate, comparator, functional interface. That's what we have discussed as part of the functional interface. I'm going to share all the Java 8 video links in the details section, so do check out for the more information. Okay, so if we want to talk about the example of how Java Stream works, the simplest way to think of the Java Stream is to imagine a list of objects disconnected from each other and entering into the pipeline one at a time. So let's say we have let's say we have stream, there is something called stream, and it is entering like at a time, let's say filter, right? So you can control how many of these objects are entering into the pipeline and what do you do with them inside it, and how you can catch them as they exist from the pipeline. So let's say we want to do some filtering. On top of that, let's say we want to perform some sorting, then we want to convert it from some type to another type, then we have a map, and at last when we are existing from the pipeline, how we are going to collect it. So this all operation is formed as a stream. That's why it is called as a stream, and Java's provided this new feature as part of the Java 8. So let's explain this with the array of the list example. So let's say we have this list example. Okay, let's say we have a list of languages of array type where we have stored different types of the languages like English, German, and French. Okay, and let's say if we want to print the list of the member which is available inside this language list. Okay, so how we can do that? So in the traditional one, how we are doing it? Using the for loop, or let's say enhanced for loop. Using that, we are able to iterate each and every element and we are printing it. But let's say if we want to use the Stream API, we can obtain the stream by calling the stream function provided by the Java 8. Then we can convert this list as a stream, and then we can perform all those operations. Like in this case, let's say we want to print each element, like how we are printing using the for loop. So Java Stream also provide one for loop in the form of this stream. Okay, so if you want to use this for loop, we will use something like this. So let's say we have a list of languages. We want to convert it, the collection of the object, into the stream. So Java provided the stream function. Using the stream function, we will be able to convert it into the stream. And after that, what are the methods available or provided by the Java Stream, we can apply it and we can use it. So let's say, for example, we want to print it. So there is a method called for each. Okay, and using this for each, we can provide the lambda expression, or we can provide the method reference. So in this case, lambda expression, we know if we want to replace it with the method references in some example we have seen already as part of the method reference. So this is how we can do that. Okay, now let's say, for example, in this case only, what are the operations that we have listed down? If we want to perform one by one, how we can do that? Okay, so next operation, let's say we have a filtering, right? So let's say this is the list of the collections or list of the object that we have. So first we need to convert it into the stream, and then we can provide the, or you can say we can use the filter method provided by the stream, and we can filter it. Okay, so filter method is used to filter the stream. Let's use the above stream example only. Filter out the languages list based on the specific criteria. That is, for example, let's say we want to print all the element which is starting with the E. So how we can do that? So first thing what we need to do, first we need to convert this object into the stream, and we know that how to do that using the stream method. So let's say, for example, in this case we have already converted it, and this is the stream. Okay, so since this is the theory part, so we are not writing all the syntax and all. We will see in the case of the example where we are going to perform in the real time in using the IntelliJ IDE. Okay, so on top of the stream we can use the filter like this. So let's say we want to filter it all the element which is starting with the capital E. So we can apply like string dot filter, and here we can provide the lambda expression. So we have learned, right, how to use the lambda expression. So it was simply syntax, and right here should be parenthesis, inside the parenthesis there should be argument. If it is a one argument, no parenthesis is required. Then arrow token, and here we need to provide the lambda body. So if it is a single statement, in this case like items dot start with, this is the simple filter, let's say capital E, so no body is required, directly we can write like this. Okay, so what it is going to do, so this filter method takes a predicate as a parameter. Okay, so we are basically using as a predicate lambda expression. So this implementation is nothing but the predicate implementation only. That's what we have seen also as part of the method references, or you can say functional interface, right? And this predicate interface contains the function called boolean test t, okay, that takes a single parameter and return as a boolean. So in this example we pass the lambda expression, right, like item tends to you can say token item dot start with something this, to test the function. So it is going to test each and every element, and if it is starting with the capital E, it is going to collect it, okay, and rest of the element it is going to return it. So when the filter method is called on the stream, filter passed as a parameter to the filter function is stored internally. So this is how it is going to filter it. So now let's say on top of that we want to perform the another operation that we have listed down here. Let's say sort. Okay, so how we can do that? So let's say this is the language list which contain the list of the object. We need to convert it into the stream using the stream method, and then on top of that we can apply this sorted method provided by the stream API like this. So it is going to sort all the element in a ascending order by default. There is another way also to sort the element in a descending order. That's what we have seen in one of the previous video. But for example, let's say we want to sort it. So this is how it is going to sort it, and it is going to store internally, but it is not going to return it. So let's say after sorting the element, we want to print it. So we know that how to print each and every element using the stream API. So we can use the for each, and then inside the for each method, we can provide the lambda expression or method reference to print each and every element. Okay. Now let's say we want to perform the next operation, that is called map. A map is going to take as an argument as a function, like in this case sorted, it is going to take as a comparator as an argument, because comparator is going to use to sort the element by default in a ascending order. We can also provide to sort the element in a descending order if we want. Okay, so how we can use the map? So basically map is a function provided by the stream API which is used to convert one type to the another type. Okay, so what it is going to do, map? So stream provides a map method to map the element of a stream into another object. So let's say previous example, convert the element of a language list to uppercase. Okay, let's say this example only. Let's say we want to convert all the languages into the uppercase. So map basically is used to convert one type to another type. So let's say we have this element. So how we can use it? So first of all, what we need to do? First we need to convert this list of the object into the stream API using the stream. Then we need to use the map provided by the stream API, and here we need to write the logic. So to convert the map, or you can say to convert one type to the another type, again we can provide like a functional interface, because this map accepts the functional interface, and we know that functional interface is what is going to accept something and going to perform operation, and then going to return another element, right? So this is how we can provide the lambda expression implementation, like item, then arrow token. There is a typo here, basically item, then arrow token, then item dot uppercase. So basically this is nothing but is going to take as a functional interface, going to convert each and every element inside available inside this list, okay, and going to store it internally, but it is not going to return until unless we call the terminate, or you can say terminal operation of the stream API. So there is a basically there is a two types of the stream API operation we will see. And then let's say we want to print it after converting, or you can say after performing the map operation, and inside that we are converting from one type to another, then we are printing it. So similar to that we can use the for each method, and here we can provide either the lambda expression or method references, whichever is applicable, because we know that some places in case of the lambda expression we can replace it with the method references also very easily, and it is going to be very convenient, right? Now next operation, let's say we want to perform on top of this list, is like collect. So we have seen how to convert the list of the object into the stream using the stream method, and then we have seen how we can perform multiple operation on top of, or you can say the resultant of one operation, like after filtering, after sorting, and then after mapping, right? So there is another last one that is called collect. So Stream API provides a collect method for processing on the stream interface. When the collect method is invoked, filtering and mapping will be occurred, and the object obtained from this action will be collected. So basically it is going to collect each what are the operations that we have performed internally, and when we are calling the collect method, it is going to collect it in some types, whichever way we want it. Like in case of for each, here we are directly printing it. Let's say instead of printing we want to collect it into some variable, and then we can perform some other operation. Okay, so how we can do that? So let's take this example only. Let's say we have a new list of the languages in uppercase, right, in uppercase as shown in here, and we want to collect it all the languages. Okay, so how we can do that? So basically we first of all we need to go one by one again. Let's say this is the list of the object contain the English or all the languages. We want to convert it, so we will perform all these operation again, like language we need to convert it to the stream, and then we need to perform what are the operations that we want to perform. Let's say we have performed like converting all the languages into the uppercase using this. Instead of printing, we can use the collect method provided by the stream API, like this, language.stream, then map, and then use the collect, and inside the collect we need to provide the output type. So since this is a list type, we need to provide the appropriate type only which is going to be collected. So let's say we want to collect it as a list. Okay, so let's say we have some list like languages, this can be languages only, and here we need to provide the collect. Inside that there is a class called collectors.toList. This is going to convert, or you can say this is going to hold all the element written by this operation into the list and going to return it, so that we can store it in some variable of type list. So what are the type we are providing it here? We need to provide those type here only, and after that what are the operation that we want to perform, we can perform it. So either we can directly print it using this sysout statement, or we can perform some min max and so on. So basically Stream API provides bunch of functionality or bunch of method. Using that we can perform different types of the operation. Like in this example we have seen how to sort it, how to filter it, how to convert from one type to another type, and also we have seen some different types of the functional interface which is going to be accepted by this method. So since it is expecting some functional interface, we can directly provide the lambda expression implementation or the method reference, whichever is applicable. Okay, so these are some couple of the example. So basically you can say this is basic overview of the Stream API. So what is the Stream API? Stream API is used to process the collection of object. So first point you have to note down here is like Stream API is going to work on the collection of the object, because on top of the collection of object only we are going to perform all those operations like filtering, sorting, converting from one type to another type, going to return find first, find net, lots of methods are there. So what is a stream actually? So stream in Java is a sequence of objects that support various methods which can be pipelined to produce the desired result. That is why we are calling as a stream, right? So we can pipeline all those operation like we have seen in this here. Similar to that, we can pipeline it and we can perform it. So main use case of the stream in Java is like stream API is a way of express and process collection of object, and next is like it's enable us to perform operation like filtering, mapping, reducing, sorting, and so many operation it is providing. So using this, it is very simple, and in a syntax basis, in a performance basis also, it is like a very simplest way, because all those operation, external operation is going to be taken care by the Java itself. So Java has provided lists of method, and using those method we can perform all those operations whichever we want. We will see all those operation whichever is possible in our upcoming video. Okay, now we have seen what is the stream, how the stream API is going to be work. Now let's see some of the features provided by the stream API. Okay, so first feature is like stream does not store element. Like we have seen, we are converting the list of the object into the string and then performing some operation. After that, it is not storing, it is storing internally the element. When we want to print it, we need to apply some operation like collect. We have seen using the collect we can store it. So the first point is like string does not store element. It simply convey the element from one source to, or you can say data structure, array, or any input channel through the pipeline of a computational operation. Next feature of the stream API is like stream is a functional in nature. It means operational performed on a string do not modify its structure. What do you mean by operational performed on a string do not modify its structure? For example, we have seen we have a list of the language object, right? So let's say if we want to perform the operation using the stream API like sorting or filtering, it will not modify the original list of the object. Basically, it is going to perform the operation on a separate object, and using the collect or using the terminal operator, we will collect those output, but original object will be intact. It is not going to change anything. For example, filtering a string obtained from a collection produce a new string without filtering the elements rather than removing element from the source collection. So source collection would be as it is. It is going to produce the new collection where you can use the collector, or you can say if you want to directly print it, so you can use the for each. So you need to store it in a new collection. So original is string going to be as it is. Okay. Next feature of the stream is like stream is lazy and evaluate code only when it is required. It means when we are performing in the operation, let's say multiple operation, when we want to perform like on top of this stream, we want to perform the filtering, and then let's say we have something sorting and then mapping. So mapping and sorting will not be performed unless filter has been performed. So it is like a kind of a lazy. Whenever it is required, then only those method is going to be called. It is not like always going to call all those methods. So it is like a lazy in nature. Next feature of the stream API is like the element of the streams are only visited once during the lifetime of stream. Like an iterator, a new stream must be generated to revisit the same element of the source. So basically stream is streaming means it is going to be flow in a forward direction. So whenever you are performing the element, it is going to perform one by one. It is not going to revisit the each and every element always. It is going to revisit each element once in a lifetime, or you can say the until the unless operation of the stream is completed. Okay, so these are some couple of the feature provided by the stream API. Now we have seen some couple of the operation. So basically stream provide mainly two types of the operation. First is like intermediate operation, and another one is like terminate operation. So intermediate operation is the operation which we are performing on top of the stream, and terminate operation is the operation where we are going to perform and going to terminate the stream operation. Like we have performed like this. Let's say we have performed like sorting, filtering, and map. So those operations are called as intermediate because still we have not stored the element or we have not completed the operation. Then later on, let's say we have performed like using the for each, we have printed all the element. So for each is kinds of a terminal operator because after terminal the stream is going to be completed or the operation of the stream is going to be completed. Similar to that, we have performed like collect. Okay, so collect is also when we have called the collect, it is collected all the element after performing all those operation like filtering, sorting or mapping. Okay, so this is the structure of the intermediate operation. So like we have a stream and here we can perform the let's say we are performing some different types of the operation 1 like filtering, operation 2 like sorting, 3 or you can say more like math. So these operations are called as intermediate operation, and on top of the intermediate operation, when we perform the terminal operation like collecting or you can say printing the element using the for each, those are called as terminal operator, and after that it is going to return some output. Okay, now let's see some sub characteristic of the intermediate operation first. So what are the characteristic of the intermediate operation? First is like methods are chained together. So we have seen how the all the methods has been chained one by one, like we have done filtering, then sorting and then map. Second is like intermediate operation transform a stream into another stream. So like we have seen characteristic or a feature of the stream is like stream is a lazy in nature. So it means it is going to perform one operation, it is going to convert those or you can say transform the output of the one operation to the another operation, whichever operation that we want to perform. Okay, next characteristic of the intermediate operation is like it enables the concept of filtering, where one method is filter the data and passes it to another method after the processing. Means once the one operation is completed, it is going to pass the result of the operation to the another operation, and then subsequently it is going to pass to the next of the operation. So likewise we can say that intermediate operations are running based on the concept of lazy evaluation. Let's say we have this operation, so this operation 2 and so on is not going to call unless operation 1 has been completed and it has passes the resultant of the operation 1 to the next operation, let's say operation 2. Similar to that, the terminal operations are the type of the operator that is going to return the result. Basically terminal operator are the operator which is actually going to return the result. This intermediate operator is going to pass the result from one operation to the another operation, but it is not actually going to return the result. Like we have, let's say, passes the input, perform some operation, and after calling the terminal operation only we are going to get the output. So terminal operation like we have seen for each or you can say collect. Likewise there are so many terminal operations, we will see one by one. So first we have seen collect, right? How we have performed like on top of this, let's say we have a list of the number, we want to convert it first into the stream using the stream method. So converting the stream also, there is a different types of the stream method provided, like we can have a different types of the object where we want to convert it into the stream. So first method is like stream method itself. Then here map, it is called as an intermediate operation where we are performing some operation, let's say we are multiplying the same number again. And after that when we calling the collect method, this method is called as terminate because after calling this we are going to return the output like collectors.toList. So this is going to tell these types of the output we are expecting. So basically this is something that we need to store it in some same types of the variable like list type. Okay, next we have seen for each, right? So let's say we have an array of list of number and we want to use the for each. So first we need to convert it into the stream, and then we can apply some intermediate operation like let's say the same operation, and after that either we can collect it using the collect method or we can use the for each if we want to print it. So we know that for each is going to accept some, either we can provide the lambda expression implementation like this, or we have also seen how we can apply the method references. So we can directly call object and then methods, right? there is another terminal operation that is called reduce. Okay, so let's say we have this number where we want to perform some operation like this. Let's say we have converted into this string, and then we are performing some filtering, like what are the number is mod of 2 equal to 0, those number is going to be returned. Then after performing this intermediate operation, we can reduce, means from where to where we want to return the result. We don't want, let's say we don't want to return all the result, we want to return the result by providing this calculation. So reduce is also kinds of the terminal operation. After performing the reduce, it is going to return all those number. Okay, so basically it is going to return the result. So whichever the operation is going to return the result is called terminal operator, like collect, for each, reduce, and there are so many. We will discuss more in detail. Okay, so these are some of the examples that we want to perform. Okay, so first operation like creating the empty string, then creating a string from collection. Likewise, there are so many operations that we have listed down here. We are going to perform all those operations using the IntelliJ IDE, and we are also going to see the actual output, how the actually it is working. So these are basically the theory part. In the next upcoming video, we are going to implement all those implementation one by one. So stay tuned. We'll meet you soon. Thank you.